Excellent. Good morning, everyone. A couple of minutes and we will get underway. Please feel free to scan the QR. There will be a quiz right before the Q&A, both of which you need the Slido. You don't need to download the app. Simply just use your phone, scan it. It will take you to a website and you'll be able to answer the quiz question and you'll be able to ask Q&A. So we'll give a minute or two just to get everyone on. Whilst we're waiting though, I will introduce my lovely assistant today, who is none other than the Queen of Norway, Linda Carlsen. Linda's been in the industry for more than 30 years. I'm not going to say exactly how many. Her careers took her around the world. She's held a number of positions and she's currently the Director of Technical Services for Europe. Frankly, what Linda doesn't know isn't relevant. She's a wealth of knowledge.
Well, let's see.
Okay, we've got a couple more people logging in. If you have just joined us, scan that QR code. You're going to need it for a few slides later. And then today's presentation, we're going to be probably 20-25 minutes of presenting. Time for some Q&A towards the end, and then we'll have like a 2-minute wrap up and we will be done. Just waiting for one more person to join and then we'll get underway. Excellent. Right, okay, let's talk about it. ISO 12944, why does it matter? ISO is an international organization standard, and 12944 specifically focuses on the paints and varnishes corrosion protection of structural steels by protective paint systems. What this standard allows us to do is it allows us to compare apples with apples. It allows us to test one of our systems versus another one of our systems. It allows owners, contractors, manufacturers to compare not only their systems internally, but to also compare them against other systems that might be available in the market that have been there for a long while, newer systems that come in. The standard ISO 12944 is separated into 9 different parts, and if anyone wants a good bedtime read, I highly recommend not. And it covers off a variety of topics. It does the general introduction, classification of environments, design considerations, tells us how many number of coats and dry film thicknesses we need. It tells us about testing that we need to do, supervision of work and safety. It also covers off additional areas, including offshore environments, which they recently added in part 9. Linda, you have some comments on this one.
Yeah, we are not going to cover all of these standards today, obviously. So what I would say is that there are a continuous revision of these standards, and now they are revising the part 6, which will be not sure when it will be released yet, but the purpose here is to try to align this part 6 more with part 9 now. So it will, in a short time, it will be a new revision for part 6. So that will also make us do, change and retest and then so on, the continuous way we are working here.
Awesome. So the 12944 separates the document out into a number of categories. What we have on this table, initially on the left-hand side, we have the categories, C1 to C5, and then CX. And here we can see that it goes very low, low, medium, high, very high, and then extreme corrosivity categories. Next to this, we have, my mouse has stopped working. Oh, there we go. In this purple box, we have explanations of what these environments look like, So C1 environment, very low corrosivity. It is not an exterior environment. It's purely internal. It's a heated buildings with clean atmospheres. For example, offices like the one that I'm virtually in, shops, schools, hotels. If we go down to, say, C4 high, we're looking more industrial areas and coastal areas with moderate salinity. That's exterior. Internal C4 could be swimming pools, coastal ship and boat yards. And then CX, we're looking at industrial areas with extreme humidity and aggressive atmosphere. And then the section on the far side, which is depicted in part 1 of ISO 12944, is durability ranges. So here they separate the durability range into low, medium, high, very high, not to confuse these durability ranges with corrosivity categories. These are separate. The durability range dictates how long a coating system should last based on testing, based on the kind of products that are put into there, which we'll see in a couple of slides later. But low is less than 7 years, medium 7 to 15, high is 15 to 25, very high is above 25. Note that CX only has one durability range, and that's between 15 and 25 years. These parts, part C1 to C5, the testing for this can be found in part 6 of ISO 12944. And for the CX, everything that's required for CX is found in that part 9. Everything from testing to systems, all of it in one place. For the remainder of the presentation today, we're going to be focusing on C3 and above. Something that I'd like to highlight is 12944 does also cover immersion. It separates it out into 4 different categories. But again, in the interest of time, today we're focusing purely on the atmospheric side of things. Okay, so in part 5 of the document, it will dictate minimum number of coats, which is MNOC, and it will tell us nominal dry film thicknesses, NDFT. This table, initially, when you look at it, it's a bit eyes all over the place. It's a bit confusing. But if we try and break it down a little bit, along this bottom bit, we have the different corrosivity categories. And then along the top, we've got the durabilities. So, and we have the abbreviations explained here. This is if we're using a zinc primer, this is if we're using something else. And then basically you choose your system down the lines, down the vertical. Okay, and if I click this one here, so if we look at C4 low, if we use a zinc primer, we can get away with 1 coat at 60 microns. If we don't use zinc, then it's telling us that we need to apply a minimum of 120 if we're using one of these kind of options, so either epoxy, polyurethane, or an ethyl silicate. And if we want to use an alkyd or an acrylic, we need to apply much higher thickness because we need to create more of that barrier properties rather than corrosivity resistance. And then equally, if we go to the other end, so if we look at C5 very high, where we're talking about we want a system to go beyond 25 years, then the document is guiding us towards a 3-coat system with zinc, a minimum of 320 microns for the total system. Okay, so that could be the zinc, the epoxy, and whichever top coat you choose. If you choose not to use zinc, then again the system needs to be that film build needs to be that little bit higher of 360 microns. And notice that they don't recommend using alkyds or acrylics by themselves in this environment.
Yeah, this is also something that of the thicknesses for the very high on C5, there are differences between, NORSOC and also ISO, so it will be defined trying to align the thicknesses also. Otherwise, it will get very confusing for us.
Yes, yeah. And one of the nice things that ISO put in there for us, which I don't believe it's in the NORSOC or not yet, the innovative clause, which allows us new innovative coating technologies might provide equivalent corrosion protection at lower nominal dry film thicknesses and or reduced minimum number of coats. What that means is less thickness and less number of coats is an option, providing there is some long field experience documented that you can prove. Maybe there's some more aggressive lab tests results that you can prove that can prove the performance of the new system. And equally, it could be a combination of the two. So new lab tests alongside proven real world scenarios.
Track record, yeah, yeah. This is also a little bit. It's if you have new technology, of course, it's difficult to get the long track record, but yeah, you just have to convince and document that it provides the corrosion protection that you need.
Definitely. And it's I find it nice that they've put this in, because sometimes some standards they will want a certain amount of track record for a product that if you've only just launched it, it's impossible to have 25 years track record.
Of course. Yeah.
And then, so this is what the testing looks like for C3 to C4, 5, and CX. So if we're looking at low, medium, and high durability for C3, C4, there's no cyclic testing. There is only this 6270, the water condensation testing, and the 9227 neutral salt spray testing. Okay, and then we can see on this table that we've highlighted it so we can see how they overlap slightly. So C3 medium testing, for instance, 120 hours of 6270 testing and 9227 at 240 is the same as C4. So if the owner or the contractor is looking for a system that they want to last between 7 and 15 years in a C3 environment, then of course this C3 medium testing is sufficient. But that same one, if they take it into a C4 environment, is only going to last less than 7 years. Equally, it then drops off completely in C5. Therefore, you need a product or a system that passes at these higher test levels. And then sorry, Linda, did you have?
No, it's yeah, it's all about they are now considering also cyclic testing for C3 and C4 as well in the new revisions. So, but today it's not a requirement, but it's an option for C4.
Yeah. Excellent. And will that be at lower durabilities, do you think?
They are considering, at least for the for C4.
Yeah.
I guess don't know the final result yet, but they're really considering it for C4 and also for C3. But in the higher,
Yeah. So at the moment, the cyclic testing is in for C4, but at the very high, when we need it to be 25 years and above, which is the same as a C5 high. Again, that level, once we go to a higher corrosivity level, of course, the durability of that same system will drop. So C5 and C4 are both 10 cycles. C5 very high is 16 cycles. And CX, which is that extreme corrosivity category, it's 25 cycles of cyclic aging testing. Here it is in another table, so you can see how they overlap again. And then you might be wondering what is cyclic aging testing. Some people on the call might be relatively new. Some people might be a lot more experienced in this. But the cyclic aging, effectively, you have a 7-day cycle. And for the first 72 hours, or the first 3 days, you cycle between UV exposure and then condensation testing every 4 hours. It flips between the two. And then for the next 72 hours, the panels go into 9227 neutral salt spray. And then for the 7th day, they go into a freezer at minus 20 degrees C. And that is what you're seeing on the screen now is one cycle, which is 168 hours. this is repeated for CX, for example. It's repeated 25 times, which is 4,200 hours. Is that right?
Yeah, 4,200 hours. And
Excellent.
this freezing, this David freezing is actually the one that makes the difference and actually stresses the system extra. And it's the difference that they might want in the new revision because it's more according to the normal environment. Yeah, what we see. And we also see that a lot in the testing that we have done. If we're comparing without the freeze cycle and not, it's quite a big difference in the results.
Mm-hmm. And then this is what the panels look like. The standard clearly defines that it has to be 75 millimeters by 150. The scribe needs to be at least 50 millimeters across. It needs to be at least 25 millimeters from the bottom, and the panels themselves, it's not on here, but they need to be a minimum of 3 millimeters. This is the water condensation tester. This is the neutral salt spray. You can see the ISO panels in here. These panels with the vertical scribe is a different test, or a different test standard. The QUV tester, so these are the ultraviolet light bulbs that then the panels face against. And in case you wonder what a freezer looks like, this is a freezer. Okay, when we evaluate the panels when they come out, we check them for blistering, rusting, cracking, flaking, scribe corrosion, and then also we do an adhesion pull-off testing. In order to pass, then all of these things, the blistering, the rusting, the cracking, the flaking, they need to be zero. There can't be any visible signs of any of these failures. And then the scribe corrosion, so the distance from the scribe itself to the very top of the creep needs to be less than 3 millimeters. And the adhesion pull-off needs to be greater than 2.5 megapixels. And here's an example of what a test panel looks like when it comes out. Here's the 3 pull-offs, and then somebody has scraped this back to see how far the corrosion has gone back. Linda, you have some comments regarding this and the interpretation?
Yeah, the interpretation, it's very visual, and of course it's difficult. And for us paint suppliers, we can get some frustrations when we are going down and see how they read the scribe, of course, because it's difficult to see. You use a template, or you have 9 measurements, you divide it and have an average, and that's what your result is. And of course, if it is 2.9 or 3.1 millimeters, it's difficult to see. But yeah, we have agreed, and so we come to a conclusion in the end always. But when you have systems that are on the limit, it is difficult, and it will be yeah. So you need to have the knowledge and the yeah have the what do you say?
The
Experience of reading, especially on rust screen.
Yeah. We would say in the UK, not your first rodeo. You need a bit more experience. And actually, this is probably the beauty of having you on here, Linda. Is I'm approaching this from very much a background of I've read the standard, I've seen test reports. I don't think there's a protective coating available in the world that's not on the bottom of your steel toe cap boots, because you've lived and breathed it and seen what this is like, both in the lab, sprayed, applied, all the rest of it. So I appreciate you bringing real world in.
Yeah. Yeah, no, I've seen it, and also just because there was many years ago, some engineer said that, oh, he see with zinc silicate systems you can get below 1 millimeter. That was the old cycle. Then you add a new cycle with the freezing cycle, and suddenly all the systems that tested below 1 millimeter suddenly were close to 3. So is difficult. And you can imagine when you're sitting in these standardization committees, it will be a lot of discussions. Everyone has an opinion, and to agree on everything, it's a long way. It takes time.
Yes. Yeah, definitely. So here's another example of a coating system that passes. So here I believe we have a 3-coat system, a zinc rich, an epoxy, and then a polyurethane. This is what the panels look like when they come out, and then what the person evaluating needs to do is, I assume you guys can see my mouse, or can you not? Maybe not.
Yeah, we see it.
Okay.
We see it.
Oh,
Yeah.
okay. So you basically scrape back these areas here, and you can expose how much of the rust has crept back, and then you measure. Is it from the center of the scribe, Linda,
You
up,
don't
or is
know,
it
it's
from
a
the edge?
total, no, you, what you do is you have a template over, you measure from the top to the next straight down, then
Hmm.
you withdraw 2 millimeters because the scribe itself is 2 millimeters.
Yeah.
Yeah.
Thank you. And then here's examples of where they fail. So we can see that these scribe corrosions are very, very high, much more than 3 millimeters than what's allowed. And then interestingly, we had to put something of our own in here. This is some test panels of carb zinc 11 and Armalast. This is what they looked like before they went into test. This is what they look like when they came out, even with the scratching back of corrosion, or scratching back to look for corrosion. And there was zero on them, even after 25 cycles. So that was pretty impressive.
Amazing. Makes me happy just to look at it.
There is a quiz on the next slide. So whilst we're summarizing and giving you a conclusion, make sure you scan this QR at the top, or you can go to the Slido website, type in this number, and it will take you, so you can be ready. Because I believe there's a timer as well. So the first person to answer, I can't really give you a physical prize. We can maybe just give you a round of applause. But conclusion, why does ISO 12944 matters? It optimizes coating performance and longevity, ensures consistent corrosion protection, guides design and maintenance decisions. Another way to word this is it allows owners and contractors to choose systems that are right for what they need. Notice I'm saying right for what they need, because often sometimes people they may want the longest lasting system. Equally, some people might just need maintenance to cover them for the next 7 to 15 years. But by manufacturers putting their products through this testing, they can clearly prove to owners that this is how long the coating system should last based on the testing that's done behind it. And it allows people to compare side by side. So everyone ready for this quiz? I think I'm going to scan it as well, just to make sure it's working. Okay, let's go. First time I've done this. Okay, so I guess you've got to join the quiz. Let's join as Carl Gibson. We have 3 people ready. Veronica, Simon, myself. I wonder if that's Simon Daly. If it is Simon, hello. Or if it's Simon Loins, hello as well. And if it's a Simon that I've not mentioned, I'm really sorry. Hello to you too. Henry, okay. I think we have a few ready to go. Emily. One more second and then I'll hit go. Excellent. Buenas, Clara. Okay. What is the extreme corrosivity category called? C1, C5, CX, CE? Excellent. Glad to see everyone's paying attention. Will it tell us who was the fastest on the next slide? Well done, Clara. Muy bien. Okay. Opening up to Q&A before we have a final little wrap up. If you have any questions, please pop them, again, scan the QR, pop them in here. What category would Antarctica be? Nice question.
Yeah.
Since technical director's here.
Yeah, and that's a little bit difficult to answer because it is extremely cold. It's ice. It's you know, it will be insulated in ice more or less, but it's not the most corrosive environment. You need to have high temperature. The higher temperature in the environment, the higher it is. But that was a good question. We are dealing with it. We are using CX as a class there, even though I'm not sure it's that high, but TX is what we at least describe Antarctica as. But depending on where you are and so on. But it will be packed with ice in some areas. It will be dry in the inland of Antarctica, so it will be different. But normally what we categorize it is as CX.
Awesome. Thank you, Linda. We have a couple more questions that came in. One from Nick. I'm not sure if it's a question though. No mobile electrolyte. Oh, is this person? Maybe Nick is helping us with the Antarctica question. Maybe that's what Nick means here.
What?
Nick, if you want to expand on that, that would be great. Or if I'm right, maybe you were helping us answer the Antarctica question.
It is dry, so it will be like nothing in the inland because it's dry. And then you come out on the coastal area, it will be C5, CX. So it's
okay. Johnny's got a question. In your opinion, which types of coatings can achieve less than 3 millimeter creep, which are non-zinc in CX?
which types of coating can achieve less than 3 millimeter? You have to have an epoxy mastic with great wetting properties, and it's difficult. It's difficult to achieve, but some coating system pass, some don't. But let's be honest, it's challenge.
Yeah, I guess you'd need, if you're going to go without the zinc, you're going to need a much higher film build as well for greater barrier properties in order to survive the. But then that said, you've still got the stripe, haven't you?
The minute you get the scribe, and the minute you get the mechanical damage, you will have difficulties. So you need extremely good wetting properties on the primer direct to the steel.
Thank you, Linda.
But it is normally an epoxy mastic, phenalkymine or a standard, that achieves less than 3.
Are there any priority with respect to countries with ISO 12944 to be implemented? The way
you just release the ISO standard, and of course it's up to each country or company to implement it.
Yeah. Which, to be fair to ISO, it's an international standard organization. It is recognized around the world. It's maybe not used as much in all parts of the world. I'm thinking like North America, but I know that people are talking more about it in North America now, because it allows people to look at atmospheric coating systems with some severe aggressive testing, which until recently there's not similar testing available in the US. So more of like the bridge market, they're leaning into ISO 12944 in North America. Is there a part in ISO 12944 that clearly defines the corrosivity category in a quantifiable way? Yes. So in part 2 of ISO 12944, there is a section, I actually have it in front of me, 5.12, where it gives you a calculation, a quantifiable calculation based on mass loss per unit per square meter. So if you know the corrosion rate of the environment that you're in, then based on that figure, you can then see whether you're in a C1 to C5 to CX environment, or if your environment is more related to one of those categories per se. So yes, part 2 is where you can find that information. If we want a demo of Carbozinc 11 and Armalast, who can we reach out to? Great question, whoever this is. I'm going to give that person some euros when I see them, perhaps. Yes, reach out to myself, reach out to Linda, reach out to if on the slide at the end, you'll see Linda and mine's email addresses. Equally, you can find us on LinkedIn. Either reach out to us directly, or if you already have a Carboline sales representative or customer service representative or tech service representative, reach out to them and they'll be happy to help. They can either do demonstrations with you. Equally, that there's some theory pieces that they can do with you, and if you invite them to your office, I'm sure they'll bring some donuts with them. I know I would.
Yeah, we are happy to make a demo.
Excellent. I thought you were going to say happy to bring donuts.
We can bring donuts as well.
Okay.
No problem.
Perfect. Right, let's go to the next one. So if we remember the slides, the panels that we had the what they looked like beforehand, and when they went through 25 cycles, they looked fantastic. This was the face not only of Linda Carlsen, but also our entire RD&I team when the panels came out. So therefore, they had the bright idea to put them back in for testing for an additional 25 cycles. This time would be 50 cycles. Surprisingly, they came out looking as immaculately as they did previously. Therefore, they put them back in for testing again, 3 times consecutively, 75 cycles. Still perfect. So they put them in for a quadruple time, a 4th time, and they came out with these results. Okay, so 16,800 hours of cyclic testing. It came out with 0 blistering, 0 rusting, 0 cracking, 0 flaking. The scribe corrosion was 1.1 millimeters.
On one of the panels.
Exactly, and the adhesion results were great. So this was absolutely fantastic. Linda, what does my question to you, 4 times through CX, does this mean that it will last 100 years, or how do we interpret it? How?
This is difficult, and you can say that we, based on the system with the track record of the actually corrosion providing primer here, the Carbozinc 11, we have track record since 64 when we applied the first time at NASA in US, and you can say, but it's difficult. But if it's untouched, everything is fine. It provides I'm sure it can last for 100 years, but we say 50, 60 years to be sure, because there will always be some erosion, depending on the environment it's in. But what we see, the clue here is that we know that an inorganic zinc will last forever if it's on the surface. But and how it works is that it just protects with building up zinc salts and so on. In addition, here we have an additional layer of silicate, non-zinc. It doesn't provide the corrosion protection like the inorganic zinc, but it at least enforces the system, so it creates some kind of barrier, so it creates a more robust protection surface, so it will last. So let's say that we can for sure say 60 years that it will provide. But I'm not sure you can just add up the cycles and yeah.
Yeah.
I'm not sure about that. I won't say that. Let's see in the future. Most probably I will be retired when it's up to 100 years, but yeah, it gives it's the longest lasting protection that we have seen, and that we have actually a track record to prove it. Yeah.
Yeah, that mixture of track record and lab results, that's fantastic.
Yeah.
Well, thank you, Linda. As always, it's a pleasure talking with you, and it's even better to do it in a public setting. If anyone does want to reach out to us, our email addresses are on screen. Again, we're on LinkedIn. You can reach us that way. And thank you to everyone that tuned in. And we'll give you
Carl.
10 minutes of your day back. Thank you, Linda.
Yeah. Thank you, Carl. See you.
Ciao, ciao.
Ciao.